Hello, I'm presenting here one more example of a probability problem. This one is also from the book and is one of the examples explained in the book, but I thought that I could maybe explain a little bit more. So you can pause the video so you read what is the situation. We have these two friends, Lydia and Anya, that are trying to meet in the museum quarter in a pre-cell phone era when people agreed to meet in a corner and had to be there at the precise time. Well, they have a little bit of a more flexible agreement, and the person that will arrive first will wait 15 minutes for the second person. So I'm going to say that my notation is going to be the following. For Lydia, I'm going to call X the minutes after 12 she arrives. So this is minutes after 12 o'clock arrival. And for Rania, I'm going to call Y, similar, minutes after 12 arrival. So what we're saying is if we want them to meet, what we want is to be there with not more than 15 minutes of difference. So we want the difference between X and Y in absolute value because we don't care who's arriving first, but the difference in absolute value to be less or equal than 15. Okay, how are we going to represent this? I'm going to need a picture here. Let me see. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Okay, so in this square, I'm going to say that this is the X direction, and this is 0 minutes, and this is 60 minutes, and this is the Y direction, and here we have the 60 minutes. So we want to see which points inside this square have a difference between the X coordinate and the Y coordinate of 15 or less, because those will be the points where they meet. I'm going to use two auxiliary lines to draw that. We have two possibilities. X minus y will be equal to 15, which means that y is equal to x minus 15. And if I want to draw that line over there, okay, let's say 15 is over here, and then this is the point 60, 45, and I need to draw the segment between those 2 points. Okay. The other possibility is that x minus y is equal to minus 15 because we have the absolute value. So in this case, it will mean that we want y to be x plus 15. So this is a line parallel to the previous one. The y-intercept is here at 15, and it goes also through this point 45, 60. So I need to put a line over there as well. Okay, so let's say, for instance, we pick the point here. I don't know, I'm going to pick here 10, 17. Here, this point 10, 17 means Lydia arrived 10 minutes after noon, so at 12:10, and Rania arrived 17 minutes after noon, so 12:17. So Lydia had to wait only for 7 minutes, so they meet. So this point over here is one of the points that are good for us, one of the points where they do meet. Let's pick another random point over here. Let's say the point here, 45, 15. Yeah, this point over here. This point is not good for us because this is saying Rania arrived at 15 minutes after 12. She waited for 15 minutes, so let's say until 15:30, and then she left. And it was only 15 minutes later than Lydia showed up. So this is not a point where they meet. Similarly, you can see that a point in this upper triangle over here will not be a meeting point over here. So in this triangle, we don't have meeting points. In this triangle, we don't have meeting points. Actually, the inequality absolute value of x minus y is less or equal than 15 is in this pink area that I'm shading over here. Yeah, so those are the good points. And if we want to find the probability that they meet, well, that's going to be in ratio the size of the whole square. So what I'm saying is that the probability that they meet is given by the area we have in pink. Those are the good cases divided by the area of the whole square. Those are all the possible cases. So we just need to find what each of those areas are, and I'll let you do that yourself, or you could even check it in the book if you wish.